10H, Chapter 7 Review, Part 2. We are now up to example number 9. We are going to use operations with functions. First function, f of x, is equal to x minus 2. G of x is equal to 3x. First operation we are going to perform is addition of the two functions. So we would have f of x plus g of x. We're going to bring our two functions together with the operation of addition. So we will say x minus 2 plus 3x. At this point, we can combine like terms. 1x plus 3x will give you 4x, and attach the minus 2. So f of x plus gx will yield you 4x minus 2. Subtraction. F of x minus g of x. Go ahead and write down your functions. X minus 2. Join it with the operation of subtraction. Minus 3x. Don't forget to distribute the minus. So this actually becomes x minus 2 plus a negative 3x. We can now combine like terms. 1x and a negative 3x gives you negative 2x, and attach the minus 2. F of x minus g of x is negative 2x minus 2. Multiplication. F of x times g of x. So we will do x minus 2 times 3x. Go ahead and distribute that 3x to every term. 3x times x is 3x squared. 3x times negative 2 is negative 6x. F of x times g of x is 3x squared minus 6x. Okay, let's divide. F of x divided by g of x. Alright, so we're going to take 3, or x minus 2, place it over 3x. If you look at our function here, you can see that we cannot simplify this any further. This would be your final answer. Now let's go back and look at each one of our operations, and now we've got to figure out what our domains are. Remember, when we have a variable x, our domain can be any or all real numbers. My functions together combined, I have x in both. I don't need to worry about any square roots, I don't need to worry about any cube roots, and I don't need to worry about any fractions having 0 in the denominator with this function. So our domain for my first function will be all real numbers. Alright, let's look at subtracting our two functions again. All we have is our variable x. We are allowed to plug in any real number that we can think of into x, and we will obtain a y value. When I bring my two functions together with a subtraction, you can see that I can still use any real number. So again, my domain is going to be all real Alright, our last function we have here is the one where we divided. Now we learned in math that we are not allowed to have 0 in the denominator. If we look at our function over here, we can see that our denominator has no other operation such as addition or subtraction in it. So we can look at our x's and we can see that we can plug in any real number individually for our functions and we would be good to go. However, now that we have a fraction and we know that we cannot have 0, then we're going to restrict our domain and say it is going to be all real numbers except 0. Okay? We are not going to include 0. If I was to plug 0 in for x, we would find that 3 times 0 is 0, and that is not allowed in the denominator. Alright, next function. We're going to go ahead and do a composite function. I'm going to take f of g of x. Alright, so this means we're going to take our function of f. Inside my parentheses, I'm putting the function of g of x, which is 3x, is going to be equal to x minus 2. What does that mean? That means now that x is going to have the value of 3x, and we can plug that into my f of x. So we would write our equation as such. X now becomes 3x. Don't forget to attach the rest of your equation. Look to see if we can combine any like terms. We're good to go. There is nothing more that we can do with this function. Again, our domain would be all real numbers. We are not restricted by any square roots or